Question 5. Question 5 is about this box here, supported by two strings BC and AB. It has weight 400 newtons, and part 1 says draw a label diagram showing all the forces acting on the box. Well, there are three forces acting on the box: the tensions in each string and its weight. So we have a tension which we can call TAB, and another tension TBC, and the weight of 400 newtons. And if we just mark the angles on, that would be 60 degrees there, and put a dotted line in, and alpha there. Part 2 of the question says that alpha is fixed at 30 degrees. By drawing a triangle of forces or otherwise, calculate the tension in the string BC and the tension in the string AB. Well, rather than the triangle of forces, I'd prefer to use Lami's theorem. Now, Lami's theorem can only be used when you have three forces acting at a point, and it relates the force to the angle opposite the force. And it looks a bit like the sine rule. It's 400 over the sine of this angle here. Let's just put in a dotted line there and see what that angle is. This has now been fixed at 30. We have a right angle there, and if this is 60, there's another 30 degrees there. So we have two 30s and a right angle making 150 degrees in total. So it's 400 over sine 150 degrees is equal to TBC over the sine of the angle opposite TBC. Now if that's 30, it means that that is 60 and 90 here, making 150 altogether. And finally that's equal to TAB over the sine of the angle opposite, which in this case is 60 degrees. As a quick check, those three angles should add up to a full circle of 360. 150 plus 150 is 300, plus another 60 makes 360. Now from that we can see that because these two fractions are equal and these two fractions are equal, TBC must be the same as 400 since the denominators are the same. So T tension in BC is equal to 400 newtons. Now we have to find the tension in AB. Well, TAB over sine 60 is equal to this fraction here, so TAB will be this fraction multiplied by sine 60. 400 divided by sine 150 degrees multiplied by sine 60 degrees. And if we put that in the calculator, we get the tension in AB is equal to 693 newtons to three significant figures. Part 3. Part 3 says, show carefully but briefly that the box cannot be in equilibrium if angle alpha is 60 degrees and BC remains at 60 degrees. Well, if that angle was 60 degrees, in effect, ABC becomes a straight line. So we've got the tensions in AB and BC, and we have the weight acting at B. Now if we resolve the weight into two directions parallel and perpendicular to AC, we can call that component of the weight W1 and that component of the weight W2. And looking at this diagram, we can see that the tensions in these strings can support the weight component W2 basically by this one pulling in the opposite direction, but there's no possibility of having a force to oppose the weight W1 component. So we can say resolving parallel and perpendicular to ABC, brackets better mentioned as a straight line, and it shows that there's no opposition to the weight component W1. And if that can't be opposed, the system can't be in equilibrium. So we can say therefore no equilibrium possible.